The first three non-zero terms of the Maclaurin series for the function f of x is equal to x cosine of x. So one thing that you're immediately going to find, well, let's just remind ourselves what a Maclaurin series looks like. So our f of x can be approximated by the polynomial. We're going to evaluate f at 0. That's why it's a Maclaurin series. It's going to be centered at 0. It's a Taylor series centered at 0. Plus f prime of 0 times x plus the second derivative evaluated at 0 times x squared over 2 plus the third derivative evaluated at 0 times x to the third over 3 factorial. We could view this as 2 factorial as well. And we keep going on and on and on forever. And what you're immediately going to find is when you start taking the derivative of f and then the second and the third and the fourth and the fifth derivative, you're actually going to have to take a bunch of derivatives here. Every time you're going to have to apply the product rule, this is going to get very hairy very, very fast. So there's actually a trick to this problem. What we want to do, we can find the Maclaurin, we can find the first three non-zero terms of the Maclaurin series for cosine of x, and then just multiply that by x. Because, if we just, x cosine of x, you could use the same thing as x times the, or another way of saying it is, the first three terms of the Maclaurin expansion for this is just going to be x times the first three terms of the Maclaurin expansion for cosine of x. So let's do that. So to do that, let's just think about the various derivatives of cosine of x. So if f of x, let me use a different letter here for the function. If g of x is equal to cosine of x, then g of 0 is going to be equal to 1. And then the first derivative would be equal to negative sine of x. So the first derivative evaluated at 0 is 0, sine of anything, or negative sine of 0, I should say, is going to be 0. And then the second derivative, well, derivative of sine is cosine, so it's negative sine, so it's negative cosine of x. And so we're going to have, so the second derivative evaluated at 0 is going to be equal to negative 1. You might start seeing a pattern here. The third derivative of x is equal to sine of x. And so if I evaluate the third derivative at 0, I'm going to get 0 again. And then when I take the derivative of this, when I take the fourth derivative, I get back to cosine of x. The fourth derivative is the same thing as the function. So the fourth derivative evaluated at 0, this is also going to be the fourth derivative. I'll write it like that. Evaluated at 0. This is also going to be the fifth derivative. Evaluated at 0. This cycles. This is going to be the sixth derivative. Evaluated at 0. This is going to be the seventh derivative. Evaluated at 0. And so what are the first three non-zero terms? Let's see. It's going to be this one. It's going to be this one. And it is going to be this one. And so we're going to have this term. We are going to, or let me just do it for cosine of x. So let me write this down. So I'm going to write, and you might already know the first three non-zero terms of the Maclaurin series for cosine of x, but I'm finding it here for us. So cosine of x is approximately equal to, the first term here is just cosine of 0. So that's just 1. And then the next one is going to be our second derivative. So it's minus 1 over 2 factorial times x squared. This is the one that involves the second derivative, x squared. And then we're going to involve the fourth derivative, and the coefficient's 1. So it's going to be plus 1 over 4 factorial times x to the fourth. If it involves the fourth derivative, well, it's going to be divided by 4 factorial. It's going to be times x to the fourth. And there you have it. These are the first three non-zero terms of the Maclaurin. Oh, sorry. This is the first three terms of the These are the first three non-zero terms of the Maclaurin series for cosine of x. And so then we can say x cosine of x. So x times cosine of x. I'm just going to multiply each of these things by x. So I'm multiplying one way of thinking, but I'm multiplying both sides of this times x. So I'm getting x minus 1 over 2 factorial times x to the third power plus 1 over 4 factorial times x to the fifth power. And we're done. And even though this might have seemed a little hairy and a bit of a long process, and some people have it somewhat committed to memory, what the Maclaurin series expansion of cosine of x and sine of x are, and sometimes e to the x as well, And then this could be a very fast process where you just multiply that by x. But as you can see, even finding that Maclaurin series expansion for cosine of x isn't too bad. If you'd done it the other way, if you just try to take the first, second, third, fourth, fifth, or all the way to the fourth derivative of this and evaluate it 0, it would have gotten very, very, very hairy.